In our last video, we looked at the three types of levers. In a type 1 lever, you have a teeter-totter. The fulcrum is between the load and the effort. This can be either advantage or a disadvantage. Now, a disadvantage isn't always a bad thing. For the ones that are at mechanical disadvantages, it actually gives you more accuracy and more speed through the joint. So most of our joints are at mechanical disadvantages and we can move very quickly through them. A type 2 lever is your wheelbarrow, where the fulcrum is here, you have the load in the middle, and you still have the effort on the end there. It is always at an advantage. So you have very rare examples, the ball of your foot being pushed up by your calcaneal tendon. That one is probably the only example in the body. I've looked for others, and others I'm like, okay, is that it? No, they're usually type 3, which is the most common one. And in type 3, you have the fulcrum, and you have the effort between the fulcrum and the load. So here, we have our fulcrum, we have our effort, and we have our load right there. It is always a disadvantage. And I might have finished writing disadvantage outside the window. So in our last installment, we are going to look at smooth muscle and cardiac muscle again. So in part 1, I went over the similarities and differences between cardiac and smooth muscle. Again, on the test, you will be asked, what are the characteristics of cardiac muscle? What are the characteristics of smooth muscle? What are the characteristics of skeletal muscle? So, cardiac muscle. We have these short branch cells, and they're joined at intercalated discs, like so. Now, the intercalated disc is actually a combination gap junction and desmosome. The desmosome is holding them really tightly together so they don't fall apart when they try to contract. The gap junction is important for physiology. What's going to happen is calcium, remember, that is what allowed skeletal muscle to contract? Well, it has the same role in cardiac muscle. Calcium is going to go through the gap junctions and sort of cause an electrical current to go through the heart cells. And it lets the next cell contract and then the next cell contract. So these desmosomes are very important. Now on the histology slide, you always look for the intercalated discs. I've actually looked up what intercalated means. It means between collated, but all I see is intercalated discs are found in cardiac muscle. So it's not very helpful. So cardiac muscle, it is very similar to skeletal muscle. It has the visible dark, light banding pattern, dark, light, or light, dark, light. So in the center, we have this M line. Wow, what a surprise. You didn't see that one coming. And this looks like a centipede or an insect dancing the Egyptian. That was a dance in the 80s. So, or was a song. Then we have actin, like this. And the actin is attached to the Z disc. So it looks like a Z. And then we have more actin. Then we have more myosin. You get the idea. It's the exact same sarcomere. We have our A band there. We have our H zone. We have our I band, etc. So it's identical for the sarcomere. Now, remember the T-tubule in skeletal muscle is just this simple T shape, like so. In cardiac muscle, what actually happens is the T-tubule goes in, and then it branches. And it goes all the way through. So it's not really a T-tubule in cardiac muscle. It's more this star-shaped thing. And that's because cardiac muscle actually has less of the sarcoplasmic reticulum. And as a result, it needs more calcium. Where's it going to get the calcium? From outside. So calcium is actually going to cause the electrical current down this T-tubule. And you get extracellular calcium in cardiac muscle. So it has less of a sarcoplasmic reticulum. Smooth muscle. People think it's boring, and actually it's very interesting. It's found in the walls of your viscera, that's your intestinal tract. It's found in blood vessels. It's found in the iris. Your erector pili muscles are smooth muscle, and they're short fusiform cells. That means it's this tapered cell like this, where it has a nucleus in the center here. And apparently this one's not getting enough sleep. You have the actin and the myosin like that. It looks like a giant eye, doesn't it? So, it has a centrally located nucleus. And what happens when it contracts, you cannot see me doing this contraction, is it sort of twists and goes down. So see, that's the relaxed. The contracted one is a lot shorter because it twisted. It didn't shout, it only twisted. It still has actin and myosin, but it has long chains of actin and then just a short chain of myosin. So you don't really see the banding pattern you do in cardiac and skeletal muscle, but it still has actin and myosin. Now, it lacks striations. It still has a thick and thin filaments. And it has these things called dense bodies. The dense bodies are attached to the thin filaments, and they are attached to the cell membrane. So what happens when the myosin pulls the actin, it's still pulling, is that it's going to twist and get shorter. So you see we have these long thin filaments, only a short thick filament. And it basically is going to pull it in and shorten it. So that is the end of our lecture on cardiac muscle and smooth muscle, and our end of our lecture on histology. The next couple of lectures are a little bit long because I'm going to go through every single muscle 20 times. So you might want to get ahead, or you might want to study, and you might want to study some more and probably study some more. So thank you very much. Have a good day.